This question here focuses on properties of circles and calculating dimensions within them. Now, the question is set up so that we're looking at some sort of scenario. So this question is more of an application question rather than just say, here's a picture, get me this property of it. So questions all centered around Alan buying identical paving slabs to make a path, and each of the slabs being a circle or a part of a circle. We're then given the circle and its dimensions here, and what we're asked is to find the width of the paving slab. Now, the first thing we need to recognize is what the width of the paving slab is, and it's actually marked on the diagram. The width of the paving slab is that length there, going directly from that side, that horizontal line, all the way to the other side of the circle. Now, it's easy to look at it and think, well, we're going side to side of the circle, it's just 2 to the radii, it's 100. Well, it's not. From the centre here to this edge here, that is a radius. So that there is going to be 50. However, C to the edge where it's marked there, that's not 50 because that doesn't go right to the end. So what we have to do is figure out a way to calculate that length and then be able to use it. Now, this is one of those questions where we're given parts of circles like this, and our thought and our brain should go straight to working with Pythagoras within the circle. Because if you look at it, we can use this information here to set up a right-angled triangle such that I can use Pythagoras to get this side here. Once I have that side, I can just add it onto the radius to be able to get the information I need. So if I was to set that up as a right-angled triangle, my hypotenuse would be 50, so it would be represented by the radius. Now, the bottom side I don't know, that's the side we're going to calculate. Let's just call it A for the moment. And then the other side is going to be half of the entire height from A to B. Because remember, we're cutting that in the middle point to make this triangle. So height from A to B is 60, which means that that half is 30 there. So now we can use this information to get A. We can remember that A squared, because it's a short side, is going to be 50 squared, take away 30 squared. Remember, Pythagoras, when we come to calculating a short side, is always subtract. When it's the longest side, the hypotenuse, it's always add. So A squared is equal to 50 squared, take away 30 squared. So what that then means is equal to 2,500, take away 900s. That then gives me 1,600. So I can use this then to calculate A by taking the square root of it. So I know that A is going to be the square root of 1,600, which in this case is going to be 40. So I know the length of the bottom of that triangle, which represents this length here from the edge to C, is going to be 40. So I can then say, it's fine, I know that part, so the width is going to be that 40 plus a full radius, which is 50. So it's going to be 90 centimeters. Don't forget your units on your final answer. So there you go. Width of that circle, 90 centimeters. Now a question like this, they're trying to make it a lot more complex than it is by applying it to a real life scenario with Alan and his paving slabs. Remember, what we have to be able to do is extract the key information. Now this first part, where it's talking about that Alan and his paving slabs, is actually something you can just put to the side. There's no mathematical expertise that comes into here besides the fact that it's a circle. But all of that is then illustrated in the diagram on the right hand side. So essentially, we could have taken this whole question, wrote that diagram down and drawn the information on it, and then just said, calculate the width. So we could have taken that whole question and rammed it down into that. Now what that means is it's actually a lot easier than we do. Now remember, a question like this, what we need to recognise is that if it's a circle, there's a part of a circle that isn't quite a full radius. So this little section here is what it was. And we do have a part that is a full radius, and wanting that width, that length, or something associated with it, we're going to have to work with properties involving Pythagoras' theorem applied within the circle. So remember that. We should be able to recognise it straight away and recall our Pythagoras, build up our triangle, and then find something to work with from there. This question worth 4 marks. First mark for constructing the triangle and knowing to do it. Second mark for getting Pythagoras correct, so the 50 squared minus 30 squared. Your third mark is for getting the correct value for A, and then your fourth mark is for getting the final value there of the width. Now, if you were to just write A squared equals 50 squared minus 30 squared, that could be taken for part 1 and part 2, purely because they'll recognise from that that you're using Pythagoras, you're using it in the correct part, and that if you were to construct a triangle and draw it the way that they wanted, you'd have actually constructed the same triangle as it. So 50 squared minus 30 squared would actually get you 2 marks if you'd just written that down. Question like this though, key thing is to identify that first part. Look at the circle, set up your right angled triangle, bring Pythagoras, and then have a crack at it. If you can do that and get in the habit of recognising the right angled triangle within a circle in this manner, a question like this can be broken down, very straightforward, and it's easy peasy lemon squeezy.